Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I hope to get you started with Class 27 on two-way categorical and simple linear regression applied to your project. This video is the first part when we will focus on the two-way categorical tables. So I'll scroll down to Class 27, and there is not a markdown file here, which means that we're going to apply this to our project. If I scroll up to the outline file, we can take a quick look at the assignment for class 27, and you can see that there's the two parts. Okay, and there are sections for each of those two parts, and the rubric is up here. If I were you, I'd probably copy this rubric down into the appropriate section and then answer the questions underneath those areas of the rubric. But here's the goal for the first half. We are going to find two categorical variables, each with from 2 to 5 levels, and then specify a hypothesis for the homogeneity of proportions associated with either your research question or at least with these two categorical variables. The 4 parts you need to complete are specifying the hypothesis, performing the chi-square test and stating the conclusion in the context of the problem, provide a plot that illustrates the data as well as the Pearson residuals that illustrates where the differences are, and then interpret that plot. All right, so I'm going to close this for a moment. I'll open up RStudio and my project file. And I will also go to the website and to the model assignment. So all of my results are going to show up in this model assignment, this bottom one. And I'm going to refer to my project in this HTML file. That's going to be guiding me, and you might use the second one to guide you. All right. So it's been a little while since we've worked on our assignment. Go to my classwork folder and the outline file. Okay, I'm going to save this file under a new file name with today's date. And I'm going to set the working directory to the source file, and I'm going to knit the file to assure that we have a file that's working. While that's going, I'm going to search for class 27 to get me down to the rubric. All right, so here's the first rubric. I'm going to copy this down into the two-way categorical analysis area, and I think, is there anything else I should do here? Probably that's fine. The other idea I had was whether to make each of these sections its own section with a quadruple pound sign. That's maybe not such a bad idea. Okay, so now I've got a little subsection to put each of my results in. All right, so let's go look at the website for the project that I have done in a previous year for this part. All right, so if I scroll down into the older files, table of contents, my computer's working really hard to knit that file. Okay, here we go. So week 11 says two-way categorical tables and simple linear regression. And we're going to click on that. All right, there we are. So the two variables I'm going to use are tobacco dependence, which I believe I've updated to be nicotine dependence in my current project, and ethnicity. Basically, our you know, given your ethnicity, are you more likely to be nicotine dependent than other ethnicities? So those are going to be my hypotheses. I'm going to grab that and come over to here and paste that in. And let me just check the markdown. Looks like it is still creating the nope, it just finished creating the HTML. Okay, great. So I believe I'll come back in a moment and tidy this up. I'm going to give myself some code to work with, and then we will go through each of those parts. Okay, the hypothesis is up there. I've got some code, right? So Control-Alt-I inserts a new code chunk, and here's some code. I'm going to grab some more code, column proportions, the chi-square test, and these are some conclusions. Would be nice to use the actual RMD file here. So I'm going to give myself a little bit of a break. Let's find some fairly unique text that we can grab. Probably this object, or this object is unique that I can search for. Okay, so I'm gonna copy my code, and then we'll come back and we'll talk through this here. In the meantime, you can probably go grab my code and do something similar where you'll be modifying your code for your own variables. Okay. So I have everything in here. I believe that, let me give a quick look for nicotine. Nicotine dependent? Yes. So that's the new variable name. That's what I want to use, not tobacco dependence. So I'm going to replace tobacco dependence with nicotine dependence because I changed the variable name. Okay. Nicotine. All right. So that I can do this in real time, I'm going to run all the data in the console by pressing the down arrow to run all the data above. That will take my computer about a minute or so. In the meantime, let's walk through the results here. Chi-square test. Okay, so the first thing we're going to do is create a table where ethnicity and nicotine, we're going to sum up the number of observations that in every ethnicity and nicotine dependence combination. With the crosstabs function, and we'll print out those frequencies. Then we're going to take those results and calculate the marginal or the calculate the proportions in each column. Okay, so here, I guess we'll find out in a second, but ethnicities must be the rows. Oh, excuse me, well, we'll find out in a moment. The margin, based on this table, the margin number 1 is that you take proportions by each row. Margin 2 is proportions by each column. All right, so it is completed. Let's highlight and run this table so we can see what we're looking at. Okay, so ethnicities are rows, and nicotine dependence are the columns. Now, I'm not convinced that this prop table is going to give us the one that we want, but let's see. Yes, I don't like margin 2. Margin 2 is saying of those people who are nicotine dependent, which ethnicity are they? And I think that's not really the right order for this interpretation. I prefer doing margin 1 so that for each ethnicity we get the proportion of people who are nicotine dependent. That, I think, that interpretation makes much more sense to me. So we have among Caucasians about 14%, African Americans 10%, Native Americans 23%, Asians 7%, and Hispanics 6%. Okay, so I think that is the order that I want to be looking at. Let's clear these plots so that they are not a distraction. Okay, so we've got our data in here. We're looking at ethnicity and nicotine dependence. We see possibly some differences here, right? Native Americans in particular, 22.5% versus 6% for Hispanics. That's a very big, that's a threefold increase at least between those three. So it looks here like we might have some differences in nicotine dependence depending on your ethnicity. All right, so now we are going to perform the chi-square test. As input, we're taking those frequency tables, and we are not performing continuity corrections, though in practice you probably do want to do that. And we'll look at the result of our chi-square test. Oh, you know what we didn't discuss before? The hypothesis. So let's scroll up for a moment and read through our hypothesis. In words, we've got, is there an association between nicotine dependence, which I'll put in these left tick marks, and ethnicity? Those are the variable names. And because the variable names are labeled descriptively, we can read nicotine dependence without a space in between it and recognize what's being said there. In notation, now this, you can probably just keep this as it is and not worry about modifying it. But it says that the null hypothesis is that for the probability, there's the equation. The probability that I and J happen simultaneously together, that's like that ethnicity is Caucasian and nicotine dependence is yes. That joint probability, that is equal to the product of the marginal probabilities, the proportion of people who are Caucasian times the proportion of people who are nicotine dependent. And if that's true, then I and J are basically independent of each other, or at least there's no association. Okay, and that is what we're testing. The alternative is that, in fact, let's see if I hover here, do I get the equation? Is that I have a not equals. Okay, versus for all row categories and column categories. I think that this is so yeah, you know what, the way I've written this is a little bit confusing. We want the null hypothesis is that this equality holds for all row categories and column categories versus the alternative that it does not hold, but it doesn't need to hold for all. It needs to not hold. It needs the not equal for at least one row category I and at least one column category J. So I think that is a better statement for that alternative. Okay, so now we're testing this association. We perform the chi-square test. We see the result down here. We have a huge chi-square statistic. Yeah, chi-square statistics of greater than about 4 or 5 are getting large, and we've got 400 here. So this p-value is smaller than machine precision. So what I've got here is I've printed out the test statistic to 3 significant digits. Okay, so if I run this, so in the chi-square object, this chi-square ETD, there's a whole bunch of values. If we look at the names in there, there's the statistic, there's the parameter, there's the p-value. So the statistic and the p-value are those, are the values that I'm printing up here. So I'm saying what the statistic is. Let's see what that is. We'll just highlight and run that. Okay, 439.32. That's right there. And I'm just going to print it out to 3 significant digits. And I'm doing the same thing down here. No reason why I'm recoding this into tidyverse language. It's just trying to do that for all my code. I'm trying to run that code. Highlight. Oh, because it's treating it like an equation. Okay, anyway, there's the p-value times 10 to the 94th power. Okay, that's greater than that's smaller than 0.05. So because we had a p-value less than 0.05, right? So this number down here is less than 0.05. We are rejecting the null hypothesis, concluding that there is an association between our 2 variables, nicotine dependence and ethnicity. Now in your case, if you had a large p-value, larger than 0.05, you would fail to reject the null and conclude that there's no association. Okay? And typically that's where the end of the analysis, that would be the end of the analysis. We need to check our model assumptions. So if we look at the expected values, recall that we need all of the expected values to be at least 5. Okay, and so if I look at the minimum expected value, which is this 80 value, it is greater than 5, so we know that all of them are greater than 5. So the model assumptions are met since the expected count for each cell is at least 5. All right, continuing on to the plot, we can print the residuals as a table. There are the Pearson residuals. Recall that it is the sum of these squared residuals that give us the chi-square statistic. And in fact, I've got some code here that does that. If you were to square them all, okay, so this 4.9 squared, this 4.9 squared value down here is 24, right? If it's almost 5 and this is almost 25, so 5 squared is 25. So that seems to make sense. And if we take the sum of that, we get the very large 439, which was our statistic from before. That statistic. Okay, so those are the residuals, and the residuals, let me bring them back up down here. These are what are going to be plotted in the mosaic plot. Okay, so we'll load this, and okay, there is a mosaic plot. Let me zoom in to make it a little bit larger. Okay, this is really interesting. So this is the first time I'm seeing this plot. In previous years, I had restricted my data set to only young adults from 18 to 25, and now I've included everyone. And we have a lot more interesting results happening here. Now, there's a few labeling things I would probably do to improve this plot. Recall that in the project file, I go through a set of mosaic plots, and I rotate the axis labels and things like that. I may take a moment at the end of this video and improve this plot to walk through that with you one more time. But I know the order of this because it's the same order as what appears in this table, and I can put them both up on the screen at the same time. The colors are these Pearson residuals, and this table here are the frequencies. And so these frequencies are the relative sizes of these groups. So, for example, Native Americans as a whole represent the smallest group. If you add both of these columns, you get about 700 people. And that's why they have the narrowest bar. It's the skinniest. Okay, so looking at this, what do we see? Well, we see any gray box in the center are consistent with the null hypothesis that the product of the row and column proportions equals the proportion in that cell. So those are sort of values we expect. Red values are smaller than we expect by chance, and blue are larger than we expect by chance. So if we interpret just the nicotine dependence column, which I think is a sensible thing to do since you can either be nicotine dependent or not nicotine dependent. If you interpret one, you basically are interpreting the other. Caucasians are more dependent than expected. Native Americans also are more dependent than expected, whereas African Americans are slightly less dependent, but it's Asians and Hispanics are quite a bit less nicotine dependent than expected. So what I see here is the contrast between Hispanics and Asians being very low, Caucasians being slightly high, but Native Americans being very high in their nicotine dependence. And that's how I will write my conclusion. Now this gets more complicated when you have more than two categories. So keep that in mind. Okay, so I've got my interpretation here, but my interpretation is going to be different than this simple one. So let me make the plot window in the bottom right corner slightly bigger. Let's see if I can do that without getting my text off the screen. Okay, so the primary causes, I think causes, okay, of rejecting the null hypothesis is that Hispanics and Asians have less nicotine dependence than expected, while Caucasians and Native Americans have higher nicotine dependence than expected. Maybe I'll say and especially, since their proportion is quite a bit higher. Okay. That's a pretty straightforward conclusion. Now notice I did not really mention the African Americans who have this light red color. I focused more on the dark red colors. I would say these lighter colors are more marginal, and if you only had a light color, it's probably worth mentioning that, but I've got really strong effects, and so I'm going to focus on those strong effects and not worry too much about the fairly weak effect of the African Americans being slightly lower, because Hispanics and Asians are very much lower and the Native Americans are very much higher. So I'll focus my attention there. And that is the end of this assignment. I will spend another couple minutes improving this plot. So you can stop the video here, or you can stick around to follow the rest. So now, so I'll do that part now. So I notice I've got this piece of code here, which rotated the plot because of this direction equals V command here for vertical. I'll say that did not really make any improvements. So Let's go to the, I think I've got this in a couple places. Sorry, my computer is being a bit slow right here. Okay. In fact, let me go to the current project file. Okay. So this is the one that I'm editing now, basically. But there is a section in the plotting area, graphing and tabulating, where we do mosaic plots, and I've got some code here for, oh, I was sure that I did. Maybe I didn't do a ton of it in this file. Okay. Correction. Let me go to the old version, down to the graphing. Mosaic plots, and notice I've got this section, customizing mosaic plots. Okay, so that's what I want under week 4, customizing mosaic. So here's a bare bones mosaic plot, and that's what it looks like. And then we can abbreviate the labels. That alone might make some improvement. Here's what I want to do. Rotate labels and justify them to the right. So now I've got my nicotine dependence and no nicotine dependence, and we can read them right to left. So I'm going to grab these 2 lines of code, go over to my plot, and add them in right here. And let's take a look. We'll highlight and run this code, Control Enter. And let's make this code a little bit bigger. Okay, so now I've got labels that I can read better. The main problem now is that the ethnicity label is on top of my labeling. So I think I fixed that in my next piece of code pretty soon. Okay, here's where I have moved the tobacco dependence variable name way out to the left, and it's this offset. Offset the variable names, and I'll talk through this in a moment. So let's scroll down to here. Okay, so the offset variable names, notice it's just a list of 4 numbers, and it's the offset in, I think the order goes top, right, bottom, left. And so I've got fairly short labels, so I'm going to just try a 5 and get rid of this old piece of code that is terrible. Okay, I think that it was too far because I think it's off the screen. Let's try a 3, and I'll run the code. There it is. Looks like 2 might be enough. Okay, 2 is enough. Now, on the top label, the yes and no nicotine dependence is really overlapping here. And it has to do with this just labels a bit, but also that we have very long labels. Let's rotate the labels. Let's see, so we rotate the labels 90 degrees. That was on the left side. Okay, well, let's try 45 on this first one and see what happens. I'm a little yeah, okay, so that did that. Do we like that? I don't think so. This may be a hard one to improve. Oh, here we go. Justify labels. Notice we've got center and right. Center was on the top and right was on the bottom. So you can give 2 different arguments. I like that idea. Justify, instead of just having all of them be right, we'll justify center and right. Let me set the rotation back to 0. This is still not going to be great. Okay. And let's see what other options I've already put in down here. Depression status. Okay, I put a title. Okay, the real problem here is that the nicotine dependence is too long. All right. So how did I learn what all these labels are? So this will send us down into a deep hole in R. And if you're interested in this, then keep following along. So let's do a question mark for mosaic, because we're looking at a mosaic plot. And mosaic, there are lots of options here, but I think that there's going to be a place, make the help window a little bit bigger. There's going to be a place where I think that there's like a secondary place where we are doing all the rotate labels and so on, because I don't see the rotate labels in here. Let's scroll down a bit. Struct plot. So there's a struct plot function which creates this type of plot. I'm going to click on there, and now I think we're going to see some spacing arguments, labeling. Let's see, do you see the rotate labels or justify labels? Oh, I can search up here. Rot. Nope. I think there's even like more options in here. So if I page down a bit, there's this struct table. This is the fun part of making plots. Sorry, that was strongly facetious. Struct table. Let's take a look over here. Okay, so now I'm just sort of bouncing around. So back at struct plot. Sometimes it's time to Google something. All right, so what do I want to do? I want to shorten the labels. Well, that's sort of that. Maybe that's a simple way to do this. I do have an example up here where I did abbreviate labels to 4 letters. That's probably the shortest path here to success. So if I abbreviate them to 4 labels or 4 letters, all of our ethnicities are already at 4 letters, so those should stay the same, and we should get new labels on the columns. Let's see what we got. Okay, so we've got nicotine dependence and no nicotine dependence. I think that is a satisfactory solution here. All right, the last thing you could do if you wanted to is provide a title. Sorry, I'm scrolling up and down, but here's the plot. Oh, if I zoom out, it breaks it. Let me zoom back in. So I do have a plot here that, it's unfortunately its title is like a mile away from the rest of the plot, but the title is under the main, so I'm going to grab that. And what's the other thing I did? I've got depression status. I think that's the depression status. That's this labeling arguments. Let me grab that as well. Margins. I think we need margins also if we're going to put a title in there with these additional labels. Okay. This has turned into a real mess. Okay, before I change the margins, let's put the title in there and see what we get. Fraction of young adult smokers. So, fraction of smokers with and without nicotine dependence by, and I didn't do depression status this time, I did ethnicity. Okay, so I'm just going to change one thing at a time. I've now added a title. I know this might be a little bit hard to follow. Okay, but I basically added one, just the main argument there for the title. Okay, and that is clearly, at least in this tiny window, it's clearly too big. We will set our plot area in this argument here to be large enough so that this plot works out fine. And I'm going to bet that I don't know, 6, 6 might do it. I was thinking about those sizes, 6 and 6. If not, I might make the width equal to 8. All right, let's see about the next thing. We've got this labeling arguments, which is just a way of improving the label of nicotine dependence and ethnicity. So it's no longer tobacco, it's nicotine dependence, and it's nicotine addiction status. I think that's right. And then we don't have depression, we have ethnicity. And that term works just fine as its label too, because it's a single word. All right, let's run this. Highlighting and pressing Control Enter. It changed this to nicotine addiction status. Okay. And nicotine, maybe instead of addiction, I'll do dependence / addiction status. Okay, and I think this is pretty good. We have not yet knitted our result, but let's do that next to see if this fits into the 6 by 6 inch window here. I'm going to bet that we need slightly more width. I also have not played with the margins at all. I don't think we're going to need them. You know the song Alice's Restaurant by Arlo Guthrie? He's got a section near the end of that awesome song where it's going to be like a sing-along, and you know everyone's going to sing, but you just for a little while there you're just sort of waiting for the guitar to come around to the top of the chorus when everyone can sing. That's what this feels like. Just waiting for the compilation to finish.